Are the integers a group on multiplication? Well, to be a group, you have to have properties of identity, inverse, and associativity. You don't have to have commutativity. If you do have commutativity, then the group is an abelian group, a commutative group, or an abelian group. Okay, if you have the identity, well, what is the identity? For multiplication, the identity is 1. So we certainly have an identity for multiplication. What about associativity? Well, multiplication is associative. Of course, we also have to check closure. That should really be the first thing we check. Are the integers closed on multiplication? Well, multiply two integers, you do get an integer. So multiplication is indeed closed on the integers. Okay, now the integers, of course, consist of all the whole numbers and 0 and the negatives. So set of integers consist of -2, -1. Of course, let's put 3 dots here, dot, 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 -2, -1, 0, 1, 2, and then 3 dots, where the dots on either end indicate that this set just goes on forever in both directions. Now that's what the set of integers is, and again we see if we multiply two of these things, there's no fractional part to either of them. We're going to get something without a fractional part. And an integer is basically any positive or negative number, or 0, not having a fractional part. Now what about inverse? Does each integer have an inverse? Well, the answer is no. Two times what equals 1? Because remember that inverses have to combine to give you the identity. Well, 2 times what equals 1? The what is 1/2, which is not an integer. So we don't have the inverse property. Integers on multiplication lack the inverse property. What about odd integers on multiplication? Well, the odd integers would consist of like -5, -3, -1, 1, 3, 5, and so forth, right? Now, do they have all the properties of a group? Are they closed? Yeah, if you multiply two odd numbers, you're going to get an odd number. So the operation is closed. If you put two of these together, you get another one of them. Okay, do we have the identity? Yeah, 1 is the identity, and it's in the set, so that's good. 1 is right there. The identity is in the set. Okay, it's associative because multiplication of numbers is associative. What about inverse? Well, we run into the same problem that we did before. No, you don't have inverses. The inverse of 3 would have to be 1/3, which is not an integer. So that the odd integers in multiplication do not form a group. Okay, what about odd integers on addition? Well, again, let's look at it. Again, you don't have a group. The problem is you have two problems. First of all, you don't have closure. If you add two odd numbers, you don't get an odd number. Odd plus odd isn't odd, so that you don't have the closure property. And another problem is you don't have the identity. And it's not in this set. So, for a couple of reasons, odd integers on addition fail to give us a group. Now, there are operations on sets of numbers that do give us groups. And you're going to have questions like that in your homework. And hopefully this will give you some guidance as to how you might answer those questions.